Hello. So in this lecture, we are going to talk more about instruction scheduling. And if you remember last time, we were discussing scoreboarding. I know it must be far back in your memories with everything that has happened. So if you need a refresher, please look again through this example we did on scoreboarding. There was no activity. And Tomasulo is basically, it came out right after scoreboarding was an upgrade, and it allows us to be even faster with instruction scheduling and execution. So I will split this lecture into, I have planned 3 smaller uh, recordings. So in this first one, let me share my screen. So in this first one, we are talking a little bit about the background. In the second one, we are going through an example, just like we did with the scoreboard. And in the third video, I'm actually demonstrating what is happening on the hardware side. And that's where I want to use my little toy that they gave me. Looks like this. It's this smart pen. And what it allows me to do is it allows me to record on a notebook, and it keeps track digitally and synchronizes my voice with my notes. So what will be produced is a PDF that has annotations, and you can click on a specific point in the notes, and it will play the audio when I was drawing that specific area of the sketch. So the sound quality will be lower. I've tested it because the microphone in this device is not the best, but you should be able to understand me. Okay, so let's get started with this section. So Tomasulo, uh, how is it different from scoreboarding? Now, first of all, what are the limitations of scoreboarding? So let me share my screen again. Uh, Share this one. So what we remember is we have functional units, and in a scoreboard we have one central location that keeps track of what's happening to the functional units. And what happens is very often we are allocating instructions to functional units, but we end up waiting for the operands to get ready. So we have a lot of stalling here, and we also stall before we write the results back in order to avoid having two things right at the same time. Okay, think about a bus. We can only send one data package at a time that can update, for example, a register table, and this leads to further delays. And also, when we have a write after write hazard, well, then we have to stall the entire remaining pipeline. Why? Because it could be that we need that register again, and we can't use it because it has not yet been like produced and executed. So one property we need to maintain is that we are basically fetching in order, so we cannot fetch further instructions if they depend or if they involve this register. So how can we resolve these issues? Now, with Tomasulo, instead of functional units, we are actually using reservation stations. So each functional unit will basically have a queue of instructions that comes into that. So think about in scoreboard, we have one queue, and then we schedule one instruction to each unit. In Tomasulo, we don't have a general queue. We will have an instruction queue, but we don't have a queue. Instead, each functional unit has reservation stations that keep track of what's where, what's going on where. Okay, we will see that in the sketch. Now, the functional units, they still stall before writes to avoid write after read hazards. And then for the problem of instruction fetch stalling for write after write, what we will do is we will rename registers. So we will no longer call it, for example, X1 if we know, okay, we can't use X1, but instead we will name it something else so that future instructions can be already distributed to reservation stations, and we don't have stalls. Now, who invented this? Robert Tomasulo, and the system is now already 50 years old. And again, a funny fact, this was one of the most robust inventions in computer science, because to date we use it still in basically the same format. The only difference is when it was invented, it was specifically designed for float point instructions, such as the scoreboard. Nowadays, we use it basically for all arithmetic instructions. The only thing we can't use it for are memory loads and stores. Okay, so based on instruction, we will have a divert. We divert into a unit that handles the memory operation and a unit that handles uh, the Tomasulo system that handles all the arithmetic instructions. Okay, so how does it look like? It looks like this here. You can see here on the left side, this would be the memory unit that is kind of independent of the Tomasulo machine. Now, instructions come in form of a queue. Okay, and then we have several functional units. For example, here we have a float point adder and a float point multiplier, actually more of them, right? And each type of unit has this reservation station. So it's basically a table that keeps track of the operands for that operation that are involved and which functional unit is actually assigned then to execute it. We also have a table that keeps track of the register names. And then we have a buffer here, which is used for the memory load. So, because usually we can only do one memory operation at a time, or two per cycle on the negative edge and positive edge. And yeah, and then we have this big fat red line. That's basically the bus that will update our tables. So the way that works is if we get a result, we are not only updating our register table, we are also updating the reservation stations. So without delay, those entries that were dependent on that registers, they will immediately be updated with the values so we can actually assign them to a functional unit. So that is the basic promise, and the difference to scoreboard is in a scoreboard we would have to first update this table and then delegate the update to the functional units, okay, if they get ready. So we have another check here in scoreboard that we don't have in the Tomasulo. Now this, the exact workings of this, I will do on the notebook. So we'll go through this step by step. Now, for now, just know that we have actually 3 steps here. We have an issue stage. This is basically here. We look at what type of instruction we have and then assign that instruction to a reservation station. Now, at some point, the instruction is executed. So we will kind of put that on the bus, and we could call this broadcast or write back. But I think I have this information here. Yeah, so we have the issue, the execute, and finally the write. Okay, that's less stages than in scoreboard. So what happens when? Now in the issue stage, we are getting the information and assign it to a reservation station. In the execute, we do the operation. We also have to make sure that we only do that when both operands are ready, and also when one of the available functional units is ready. And write back, we can only write back if the bus, which is also called CDB, is idle. Okay, and then we can push it to all the registration stations here, here, and also to the register table. Yeah, so what happened to that register renaming? How does this work? Now, basically what we want to do is when we have an operation such as here, a division and then an addition, and both of those write the same register. So what we do is we will assign a new register to the next instruction, but we have to keep track of that we renamed F0 to F8, because otherwise we will end up, like doing nonsense. So we need to keep that information. And where do we keep it? In this table here, the FB registers table. Yeah, so this is the basic intro on Tomasulo, and now we will look into first how it works, and therefore I will use my notebook, and then we will come back to the slide deck and do this example. Okay.